You are welcome back to the channel. This is Dan, and in this video we have this question. We are going to use conditional probability approach to solve this. It says that an engineer buys product from two suppliers. Supplier A provides 60% of the products. Supplier B provides the remaining 40%. Supplier A has a defect rate of 5%. Supplier B has a defect rate of 8%. Then the first question, draw a tree diagram to illustrate the above information. B, calculate the probability of buying a good product. C, given that a batch of product is good, what is the probability that it came from product A? And the last question says, given that a batch of product is defective, what is the probability that it came from supplier A? So we are going to take out the data from this. We'll draw a diagram to represent supplier A and B, and we'll draw the tree diagram. Let's see what we have here. So the first thing we'll do, let's draw a diagram to represent supplier A and B. So we have this. So let's assume that we have supplier A here, supplier B here. Their intersection here will represent D. Okay, very good. So now let's pick out the data for supplier A. D here is the defectives that were recorded. So now let's pick out the probabilities. Probability of A was 60%. So P of A, this is our data, gave us 60%. When you divide this over 100, you are getting 3 over 5. Then we have the probability of B, gave us what? 40%. This is giving us 2 over 5. When you change this into decimals, we have 0.6 and 0.4. Then in the next thing, he said that supplier A has a defect rate of 5%, supplier B has a defect rate of what? 8%. That is a conditional probability. So we learned from the introductions that a conditional probability D, P of D, as A occurred, giving A, okay, defective that were recorded from supplier A. So this is 5%, giving us 0.05. The next thing is what? Probability of D as B has occurred. Okay, so as B has occurred, this is how we write it. So now we are looking for the defective that is coming out from B, giving what? B. So that is what? 8%, and that is giving us 0.08. Now the first question was draw a tree diagram. So we will draw our tree diagram like this. Because we have two events, two suppliers, the tree will have two branches. So this is the first branch, this is the second branch. So this is supplier A, this is supplier B. Now what is the probability of supplier A? We will put it here. P of A gave us what? 3 over what? 5. And P of B gave us what? 2 over what? 5. Now we move on to the next branch. We will split into the next branch. The defective and non-defective will go here, but because we have the data for the defective, we will put it here. Okay, probability of D as A has occurred, or probability of defective resulting from supplier A is giving us 0.05, and this one, probability of D resulting from supplier B, gave us 0.08. So I think you can present this for the examiner as your tree diagram. You can also decide to branch this into two. Okay, when you subtract this defect rate from 1, you get the product that were non-defective, and you can write it there. That will give you probability of good product as A has occurred. Okay, so you can use J to represent the good product. There's no need for that. So let's move on to the next question. It says calculate the product of buying a good product. Okay, so let's use J to represent good product. Now we are going to assume if the products, some are good, then some will be bad. Okay, so that will be for D. So now let G be the good product and D be the defectives. Now if we can calculate the probability of buying a good product, it's very simple. The only thing you need to do is to find the probability of good product from supplier A and also find the probability of good product from supplier B, and then sum up the result. Okay, from that we can find the probability of buying a good product. The question has already given us the defectives. Gave us that supplier A brought a defective of 5%, supplier B brought a defective of 8%. Now we know that the probability of good product and that of the probability of the defective product should give us 1. So it is easy for us to find the probability of what? Good product. So how do we find it? We will first find the probability of good product for supplier A. Okay, so P of good resulting from A given A is equal to 1 minus this. Okay, 1 minus probability of what? The defective given A. And this is giving us what? 1 minus 0.05. 0.95. In the same way, we have to calculate for supplier B. So probability of good product coming out from supplier B or giving B is given by 1 minus P of the defective coming from supplier B is giving us 1 minus 0.08, and this is giving us 0.92. So now we can use this data to calculate for the probability of what? Buying a good product. If I use conditional probability, let's take probability of G as A has occurred. If I'm changing this to conditional probability, it's going to give me either J intersection A or A intersection J. Okay, it's still the same thing. So let me use G intersection A divided by probability of what? A. P is supposed to be here. Okay, when I cross multiply here, know that this is over 1. Then I'm going to get P of G as A has occurred. Okay, this time you forget about A as a supplier. Let's deal with A as a variable. As A has occurred, we'll multiply the probability of A, giving us G intersection what? A. And this is what we are interested in. And if we need this, we need to find these two, and we already have the result. We know this and we know this. That is what is going to help us to calculate for the good product generated by what? Supplier A alone. Now let's calculate for the probability of G. The probability of good product is going to give us the event A and G occurring together. Okay, so it's going to give us A intersection G, okay, union probability of B intersection G. Know that union here means addition. So I'll clean here and put plus here. And I explained the formula earlier. So what will happen is that this is going to give us the probability of A times its conditional probability. What is the conditional probability of A for the good product? It was this, isn't it? So we have probability of G as A has occurred plus, then we go to the supplier B, probability of supplier B times its conditional probability, this. So probability of what? G as B has occurred. So now this becomes, what is the probability of A? So we have 0.6. What is the probability for this? 0.95, which is here. Okay, plus probability of B gave us 0.4 times 0.92. Do you understand now? So when we multiply this, what do we have? So this is giving us 0.57. Please cross check these values for me. Sometimes I make errors. Plus, when we add this, we have 0.368. So the probability of good product is giving us 0.938. Add these two together and cross check the values. If I make a mistake, you correct them. Okay, so when you round to 3 decimal, you have 0.938. So this is the probability of what? Good product. Now let's move on to the next question. It said, given that a batch of product is good, now we know good, okay, what is the probability that it came from supplier A? So he's looking for what? Probability of supplier A, given that the product is what? Good. This one. Okay, so he gave us good. This is the condition. So we are conditioning on what? G, that the product is good and it is coming from supplier A. So we are finding probability of A given G. So that formula is giving us the conditional probability A as G has occurred or as the product is good will give us probability of A intersection G, probability of A and G occurring together divided by the one they gave us to condition on. You take the probability of that, P of what? G. So now watch here. When we calculated for A intersection G, which is the same as G intersection A, what did we get? It is the probability of A times the probability of G as A has occurred. We got 0.57. Okay. So this is giving us 0.57 divided by the probability of good product is 0.938, and this is giving us what? 0.608, and that is the final answer. Now we move on to the next question. Now watch. Given that a batch of product is defective, now we are going to condition on what? D. What is the probability that it came from supplier A? Now we are looking for the conditional probability of supplier A given what? D, the defective. Now you understand. So this is going to give us the same thing, probability of A intersection D, giving us probability of what? D. Now I want you to come back and look at this drawing. We realize that the defective was shared among the two. A portion of supplier A brought a defective, which was where? It was here, 5%. And then B, he also brought a portion of defective. Probability of D coming from supplier B was 0.08. This data will help us to find D. Now we need to find this particular D, okay, and we will find the D for supplier A and we'll find D for supplier B. We sum the result together like we did here. So now we need probability of D is going to give us the probability of A intersection D happening together. He brought the defective, so the event happened together. Union probability of supplier B intersection or D happening together. You don't need to bring this. I usually use it to explain. So when I clean this, I'll just put addition here. So now we need the probability of what? D as A has occurred. This is the defective. When coming out from supplier what? A. And the result is giving us A intersection D or D intersection A, whatever way you want to write it, divided by the probability of the one we are conditioning on. We are conditioning on what? Supplier A. So this is how you write the conditional probability formula, okay? If it is D as A has occurred, then A intersection D over the probability of A, because we are conditioning on this one. If you interchange the variable, you are conditioning on what? This one, okay? So now, like I explained earlier, once this is over 1, once we cross multiply here, what are we having? We have probability of A will multiply its conditional probability. P of D as A has occurred will give us A intersection D. Remember, A intersection D is equal to what? D intersection A. Okay, so this side is what we will use to replace here. So what we have, this becomes the probability of A times its conditional probability, D as A has occurred, plus, then we do the same thing for what? B. Okay, supplier B. So the probability of supplier B times his conditional probability, D as A has occurred. Okay, now this becomes, we already know their conditional probability, the defective that was brought by supplier A and supplier B, which is here. We have it in the tree diagram, which is here. So we know the probability of E to be 0.6 times this guy own, which is what? 0.05 plus, this is giving us 0.4 from there, then times 0.08. Okay, punch this and see the answer you get. This is giving us 0.03 plus 0.032. Okay, now when we add these two results together, we have the probability of D, which is giving us 0.062. Now we are not done. Now we have probability of D, which is here. So the question was asking us that, given that a batch of product is defective, that is the condition. Given that a batch of product is defective, what is the probability that it came from supplier A? So he's telling us to find P of A, probability of supplier A, given that the product is defective. We already know D, which we did here. So this is giving us the conditional probability formula will be what? A and D occurring together divided by the probability of the one we are conditioning on. Probability of what? D. If A is here, it means we are going to condition on A like we did there. Do you understand now? Now we know A intersection D or D intersection A, which is here. We took the probability of this and its conditional probability, giving us 0.03. So this result is giving us 0.03 dividing what? The D, which is 0.062. 0.062. When you solve this, the result is 0.484. So we can say the probability that it came from supplier A is giving us 0.484. So that is all for this one. Now, there was something that I was supposed to tell you here. Because I wanted you to understand this principle, I used this formula to find the probability of D. Remember that I told you that the product can either be good or bad or defective, okay? So there are some. When we add the good and the bad product together, we should have one. So the easiest way you could solve this place without using this whole formula is to subtract the probability of good product from 1. Remember that we got the probability of G. So when you subtract that result from 1, you should have 0.062. So probability of D, P of D can also be equal to 1 minus probability of what? G, which is giving us 1 minus 0.983. So now this value was probability of J. If you go back, forward and go back, you get 0.983. So this result is giving us 0.062. So those of you who do not want to go through this formula, it might waste your time. You can use that way. If you really understand the question, you don't need to go through this step. But this is the conditional probability what? Formula, which is called the total probability formula. Okay, and this will help you to understand the concept very well. So this is Daniel. Please subscribe to this channel if you haven't. Share these videos with your friends if these videos have been useful to you. I will see you in the next one. Let's see if we can take more exercises under this.